Hi guys, welcome back to my channel. So how are you guys? I think you had a nice summer break. Did you enjoy your summer break, guys? Now we have to focus and please come back to the studies. Yeah, some they have summer break in the back home, and some they have summer break here. Now we know that schools and colleges also started. Then please turn to the studies, turn to the work. It's a kind of work. Studies is a kind of work. So please focus on your studies. Now I'm going to teach you shape of the molecule. Let's start. Okay. Now see that it's a it's a kind of covalent bonding in that we have the shape of the molecules. In the shape of the molecule, definitely you will get 3 to 5 marker, mostly 3 to 5 marker. And I'm sure uh, the way I'm going to teach the shape of the molecule, you can't find this type of explanation in any textbook. Let's start. To go through the shape of the molecule, we have to go through the periodic table. Let's start with the periodic table, and I'm going to start with the group 4. Group 4, group 4 elements. Agree? Yeah. Now see, group 4 elements. Group 4 we have carbon, silicon, and germanium, tin, Pb. Tin Sn and Pb, tin Pb. Let's see the group 4 elements. Sn, Pb. Now, if the central atom is from group 4 and having 4 bonded electron and no lone pair. Now let's see the shape. If the central atom is from group 4, if the central atom, what is meant by the term central atom? Central atom is the only one atom and having many other monovalent or mostly halogens around it. So if the central atom is from group 4, having having four four bonded pair of electrons and no lone pair, no LP, no lone pair. If the central atom is from group 4, having 4 bonded pair of the electron and no lone pair, our central atom is from group 4. If the central atom is from group 4, having 4 bonded pair of the electron and no lone pair, the shape is always tetrahedral. Shape of the molecule, the shape of the molecules of the molecules of the molecule is TD, is tetrahedral, perfectly TD, tetrahedral. And a BA, what's BA? British Airways? No, BA is the bond angle, and a bond angle is always 109.5. So what's the condition? The first condition is if the central atom is from group 4, having 4 bonded pair of electron and no lone pair. Central atom, anyone, you can pick anyone. Carbon having 4 bonded pair of electron and no lone pair. Then the shape is tetrahedral, perfectly tetrahedral, and the bond angle is 109.5. Can you give me some more example by choosing central atom from group 4? Yeah, hydrogen or any halogen. Any halogen. You can take any halogen. You can take any halogen, fluorine, chlorine, bromine, iodine. You can take. So methane, CH4. Carbon is the central atom in CH4. Look at that. Carbon is the central atom. Either you can take hydrogen or any halogen atom, like fluorine, tetrafluoromethane. What's the bond angle? 109.5. And what's the shape? TD. I can give you many examples, guys. Carbon, what's the bond angle and shape of SiH4? Like methane, this is called silane. Same thing, 109.5. TD, tetrahedral, tetrahedral. The short form for tetrahedral is TD. Can we take chlorine, CCl4, carbon tetrachloride? Yes. What's the BA? What's the bond angle and what's the shape? Shape is tetrahedral. Bond angle is 109.5. Trichloromethane, dibromomethane, Br, thiiodomethane. All they have bond angle 109.5, perfectly tetrahedral, and each angle, this angle, this angle, this angle, that angle, all are 109.5. They are exactly at equidistance because there is no lone pair. I'm coming to the lone pair. So when we will get a tetrahedral geometry, the central atom is from the group 4, having 4 bonded pair of electron and no lone pair. These are the conditions. What's the condition? Central atom is from group 4, having 4 bonded pair of electron and no lone pair. You can give any example, guys. SnCl4. What's the bond angle and shape? Tetrahedral, and a bond angle 109.5. Why I was telling to you, we are going through the periodic table. So to learn the shape of the molecule, we have to learn and find out the central atom belongs to which period. That's the most important point, and that's concern. That will help to find out the shape of the molecule. We can't memorize, guys, because in the examination you will get any example based on TD shape. Now, after the group 4, I want to jump to the group 5 element. I want to move across the periodic table. Then I want to go to the group 5, and let's see. Group 5 elements. So central atom is from group 5. Now, group 5th element or group 5 element, same thing. Group 5 elements, you can write group 5, or in some periodic table I have seen 15th group. Why it is called 15th group? They included 10 group from the transition metal. Actually, it's group 5. Group 5 elements: nitrogen, phosphorus, arsenic, antimony, bismuth. I need this space. I'm sorry. Group 5. So group 5 elements: nitrogen, phosphorus, arsenic, antimony, bismuth. If the central atom is from group 5, having 3 bonded pair of electron with 1 lone pair. How many electrons are there in the valence shell of group 5 element? 5. That's why they are placed in group 5. So there are 5 electrons in the outermost shell. Out of 5, they form 3 covalent bond with a 1 lone pair. So if the central atom is from group 5, if the central atom is from group 5, or group 5th, having 3 bonded pair of electrons and 1 LP and one lone pair. and one lone pair. Then what's the shape and what's the geometry? Sorry, geometry and shape is very similar. What's the shape and a bond angle? Let's see. What's the condition? If the central atom is from group 5, having 3 bonded pair of electron and a 1 lone pair, then the shape of the molecule, of molecule is, any idea? Then the shape of the molecule is trigonal pyramidal. Then the shape of the molecule is trigonal pyramidal. It is not a planar molecule, guys. This is a 3D molecule. Look, central atom is group 5, having 3 bonded pair of electron and 1 lone pair. Hydrogen, hydrogen, hydrogen. Look at that. It's like a tripod of the camera, guys. These two, look at this, is the white plane of the board. These two bond, which is wedge bond, coming towards you. Agree? And the dotted bond, it's towards me. That a dotted bond is just inside, goes inside the board, or it's away from the student. That's two are coming to the student. There's 2 bonds. Look at that. These 2 bonds are towards you guys, and that's towards me. This is like a trigonal pyramidal molecule with a 1 lone pair. So what's the condition? The condition should be if the central atom is from group 5, having 3 bonded pair of electron and 1 lone pair. Okay, I can give you many examples. Now, what's the shape of the molecule? Trigonal pyramidal. And what's the bond angle? Bond angle, look at that. Bond angle we have seen just now for methane. The shape is tetrahedral. Central atom is from carbon, and the bond angle is 109.5. When you move from group 4 to group 5, there's a presence of 1 lone pair. Due to the presence of 1 lone pair, the bond angle slightly decreases due to the repulsion between the bonded pair of electron and lone pair of the electron. So, presence of 1 lone pair, we can decrease the bond angle from 109.5 to minus 2.5. So, presence of 1 lone pair decrease the bond angle by 2.5. So, how much is the bond angle now? 107. Shape is trigonal pyramidal and it's a 3D molecule. Look at that. So 2 bond towards you, these 2, these are called the wedge bond. Sometimes they will ask to draw 3D shape, especially in case of the transition metal complex. These are towards you guys, and that's going into the board, into the white plane. Yep. So 107. The bond angle is 107 due to the presence of 1 lone pair. I will give you one question. After finishing all the example, I can give you many as example. Like look at that. Group 5, and how many elements? 1, 2, 3, 4, 5. 5 times 5. I can easily give you 25 examples. Let's see. All they have 107 bond angle, and the shape is trigonal pyramidal. Shape of the molecule is trigonal pyramidal. See that? Okay. Can I rub the board? Now, see the examples. I can give you 25 examples. Look at that. Group 5 and 5 elements. So, I will give you 25 examples. And all they have bond angle 107 and the shape is trigonal pyramidal. Let's see. Can you give some example? I told you either hydrogen or halogens, which is a monovalent atom. You can use all the halogens like nitrogen, then phosphorus, arsenic, antimony, bismuth, attached with 3 hydrogen, NH3, PH3, phosphine, ASH3, arsine, antimony, bismuth, bismuthine, stibine, and bismuthine. All they have, what's the shape and what's the bond angle? Trigonal, pyramidal, and a bond angle 107. How I know? I told you, you have to focus the central atom. If the central atom is from group 5, having 3 bonded pair of electron and a 1 lone pair, then the shape is trigonal, pyramidal, and the bond angle is 107. Now look at that. One more example: nitrogen trifluoride, nitrogen trichloride, nitrogen tribromide, nitrogen triiodide. All they have, you can use all the halogens. So all they have same bond angle and the shape is trigonal bipyramidal. Use the phosphorus PF3, PCl3, phosphorus trichloride, PBr3, phosphorus tribromide, PPI3 triiodide, AsF3, SbF3, BiF3. AsCl3, that was a past paper question, SbCl3, BiF3, sorry, BiCl3, BiCl3, here AsBr3, SbBr3, BiBr3, bismuth tribromide, last one As triiodide, Sb triiodide, Bi triiodide. Look at that. I told you 25 molecule, 5 times 5, 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5. You can count 25 molecule. These 325 molecules have same shape, trigonal, pyramidal, and a bond angle 107. One, before I want to stop here, I want to give you one question, guys. That was a past paper question. Look at that question. Just you can easily answer that question. If you want, you can copy that question with me. The bond angle in methane is 109.5, whereas the bond angle in Ba in ammonia or NF3 or anything in ammonia, let's take ammonia, why NF3? In ammonia is 107. Why? Explain. Explain why there is a difference. Explain why there is a difference. Whenever you come across explain, you can't just write one word. The bond angle in methane is 109.5 because there is no bond pair lone pair repulsion, whereas in case of ammonia, most of the students, they try to mention because of the presence of lone pair. Yes, I do agree, but you have to use the key term. In ammonia, the bond angle is decreased because be a decrease in ammonia, bond angle is decreased in ammonia in NH3. Why? Because there is a repulsion between lone pair and bond pair, LP lone pair and BP. That's why. No doubt, because of the presence of one lone pair, the bond angle is decreases. But what's the actual reason, guys? The actual reason is there is a repulsion between the lone pair and bond pair. The degree of repulsion we work out like this: LP, lone pair, more repulsion. We will come across soon this type of example, which is greater than LP, lone pair, bond pair, which is greater than BP, bond pair. Okay, guys, please keep on watching my videos, and I will come back to you very soon. Thank you so much.